Welcome to Gmat Genie. Today we are going to look at geometry problem. Before we start off with the geometry problem, note down the website address. It is www.gmatgeniesco.com. Email ID is gmatquant@gmatgeniesco.com. Address you can note it down, and the cell number is 9611897630. So in this particular video we are going to solve one geometry problem for which we would require three concepts to understand. We will go through those concepts one by one and then we will try to solve the problem. Okay, so let's go ahead with the problem. So if you can look at this problem, it says that in the circle above PQ, the PQR or the chord PQ is parallel to diameter OR. Okay, OR is the diameter, and if you join O and P and Q and R, right, then it becomes OPQR, right? That is, if you join O and P and Q and R, then it becomes OPQR, a quadrilateral, right? Now a quadrilateral inside a circle is called cyclic quadrilateral, right? A cyclic quadrilateral is the one which is inscribed within a circle. Okay, so you have a quadrilateral with four vertex, which is O, P, Q and R, right? If you join O and P and Q and R, it becomes a cyclic quadrilateral. Now one of the properties of a cyclic quadrilateral is that if a quadrilateral is inscribed within a circle, then the sum of the opposite angles, right, sum of the opposite angles would be 180 degree, right? So angle POR plus angle PQR would be 180 degree. Similarly, angle OPQ and QRO, summation of that would be 180 degree. Okay, so that's the properties of the cyclic quadrilateral, right? Now the second thing you need to understand, which is that if you need to figure out the length of the arc PQ, right, then you must know what is the angle it subtends at the center. So let's say the center here is, you might call it, let's call it as a C, right? So the angle subtended by the arc PQ at the center, okay, if we know that angle, right, if let's say PCQ equals theta, then the length of the arc, which is T, times the total circumference length, and the total circumference length we can figure it out because we know the diameter, right? So the total circumference length would be pi times diameter, right? So that's the second concept we need to know. And the third concept that we need to know is that any angle that is formed by an chord or an arc at the circumference of a circle. Okay, so what we saw was, so we've drawn a circle, right, and let's say circle's center is this one, which we call, let's say, C, okay, and then we have OR, right, so diameter of the circle. So let me draw the diameter of the circle, which is OR, and then we have the arc, okay, let's call this, okay, the arc is PQ, right? We also know that PQ is parallel to we know that PQ is parallel to OR, right? Okay, so we know PQ is parallel to OR, right? Now what we are trying to say that first one we said that this is a cyclic quadrilateral, right? So first let's combine that. Make it a cyclic quadrilateral, okay? And then okay, let's use a lower. Okay, now we saw that this is this angle, the angle ORP is given as 35 degree, right? Okay, now we as we said, this is a cyclic quadrilateral, right? So the sum of the opposite angles would be 180 degree. Now there is another thing that we need to know, that the diameter, that is OR is the diameter, OR is the diameter, and the length of the OR, which is given as 18, right? So other thing we need to know is the diameter always subtends an angle of 90 degree at the circumference of the circle, okay? Any diameter, okay? Diameter of any circle will always subtend an angle of 90 degree at the circumference of the circle. What it really means is that angle OPR, right, will be always be 90 degree, right? So we now have the triangle POR, right, the of which angle OPR is 90 degree, PRO is 35. So the third angle would be 180 minus the summation of 90 plus 35. So it becomes 55 degree. Okay. Now once we know the angle 55, angle POR, right, which is 55 degree, then we can also figure out what is the angle of PQR using the same principle of cyclic quadrilateral, right? So this will be 180 minus 155, which is 125 degree, right? Okay, so we know now angle PQR, right? Now we need to figure out, as I said, this angle, we need to figure out angle PCQ, right? If you know angle PCQ, which is theta, let's say in this case, which we are assuming, if you know angle theta, then we will know the length of the arc PQ by the formula, okay? So to figure out angle PCQ, we need to find out angle PRQ, because the arc PQ, as I said, the arc PQ will make whatever angle that it makes. Let's call this angle as angle PRQ as, let's say, beta, okay? Okay. So arc PQ is making an angle of beta at the circumference of the circle. It will make an angle 2 times beta at the center, right? So what we are saying is that angle PCQ will be 2 times angle PRQ, okay? Now we need to find out what is the angle PRQ, okay? So angle PRQ would be equal to 180 degree minus, right, angle RPQ plus angle RQP, right? Because the summation of all the three angles in a triangle should be 180 degree, right? Now we know angle RPQ. Angle RPQ is this angle, right? This angle is equal to 35 degree, because we know that PQ is parallel to OR, right? Go back here, that's what is given in the problem, right? So angle QPR and angle PRQ PRO, these are corresponding angles, right? So this will be 35 degree angle, which is angle QPR. Angle QPR will be same as angle ORP, because PR is cutting two parallel lines, right? Parallel lines are PQ and OR. So angle RPQ is 35 degree and angle RQP is 125 degree, right? So we get the angle PRQ as how much? 20 degree, right? 180 minus 160, right? So this is 20 degree. So we know angle PRQ, right? So as I said, so the angles formed at the center, which is C, by arc PQ will be twice the angle PRQ. So angle PCQ becomes 2 times 20, 40 degree, right? So now we know what is the angle which is formed at the center, which is C, by the arc PQ, right? Which is 40 degree. So what is the length of the arc? So length of the arc will be length of arc PQ will be equals to theta upon 360. Theta here is 40 upon 360 degree, right? Times the circumference of the circle. Circumference of the circle is pi times diameter, which is 18, right? If you solve it, it becomes equals to 2 pi. So the answer for this problem is 2 pi, which is the length of the arc PQ. So just to summarize, there are not 3 but there are 4 concepts here which we need to understand. Is first one is that, let me reiterate those. First one is that any diameter which is OR will always make an angle of 90 degree at the circumference of the circle. That's the concept number 1, right? Second, if it's a cyclic quadrilateral, the summation of the opposite angles would be always 180 degree, right? So that is a second concept. Third concept, any arc, okay, any arc, if it makes an angle of beta, right, at the circumference of the circle, then it will make an angle of 2 times beta at the center of the circle. That is, angle PCQ will always be 2 times angle PRQ, right? So that's a third concept. And the fourth concept is about this formula, where is the length of the arc PQ will be given by the angle subtended by arc PQ at the center, that is theta, upon the total complete one cycle angle, which is 360 degrees. So 40 upon 360 times circumference of the circle. Since we know the diameter, we can figure out the circumference, which is pi times 18. So these are the 4 concepts which you need to solve this geometry problem. I hope this tutorial was useful, and if you have any queries, do contact us on the cell number or on the email ID that is given on the first slide that we discussed in this tutorial. Thank you so much.